where we're diving into a massive and frankly kind of wild paradigm shift in the global AI race. Right now, almost everyone out there thinks the benchmark leaderboard is the ultimate prize. But the real game? It's being played completely underneath that. Today, we're breaking down a fascinating body of research that explains why the race has fundamentally changed from who has the absolute best model to whose models become the base layer everyone else builds on.
Here's our roadmap for today. We're going to cover 1. The frontier versus stack distinction, 2. The open weight enforcement trap, 3. Inside the distillation loop, 4. The standards capture phenomenon, and finally, number 5, achieving architectural substitutability. Let's get right into it.
So let's start with this absolute core thesis. China does not need to win the frontier to win the stack. Now, to be 100% clear here, nobody is claiming China has quote-unquote won AI or surpassed the US in top-tier cutting-edge capabilities. They haven't. But capturing that base infrastructure layer, the foundation that everyone else builds upon, well, that's a much more durable prize than just holding the trophy for frontier supremacy.
All right, Section 1, the frontier versus stack distinction.
We've really got to shatter the illusion that there's only one game being played right now. There are actually two. You've got frontier supremacy on one side and stack dominance on the other. US strategy is intensely focused on frontier supremacy, building the smartest, most advanced models possible. But here's the reality check. Most everyday, real-world production workloads, they never actually touch that frontier. Enterprises are simply routing tasks to the cheapest model that's, well, good enough to get the job done.
Think of it like a split screen. On one side, you have the leaderboard. These are the absolute best models out there, but they're gated, they're closed, and they are expensive. On the other side, you have the foundation. These are those good enough and super cheap open weight models. The crazy thing is, you can literally win every single benchmark on that leaderboard, but completely lose the foundation layer where global developers, universities, and businesses are actually building their day-to-day apps.
So you might be wondering, why can't governments just block those alternatives? Which brings us to Section 2, the open weight enforcement trap.
This is exactly what we call the open weight enforcement trap. Right now, Washington is heavily focused on frontier gating, basically trying to lock down physical chips, closed models, and hosted APIs. And sure, you can put a fence around those, but you absolutely cannot export control an open weight model. It's essentially just a freely downloadable numerical file. Once it's out there and downloaded worldwide, there is no recall button. Every time you add a new compliance hurdle or friction point to those closed systems, you're practically pushing builders straight into the arms of the ungateable alternatives.
And once those floodgates are open, they are open. Which leads us to Section 3, inside the distillation loop.
We have to look at the mechanics of why these open weight models spread like wildfire. It's an engine called the distillation loop, and it happens in 3 steps. Step 1, cheap access and permissive licensing immediately drive early adoption. Step 2, all that adoption naturally creates derivatives, fine-tunes, adapters, and a massive ecosystem of tooling. And then step 3, because of all those derivatives, that original base model cements itself as the default starting point for the next wave of builders. It's a feedback loop. Adoption feeds derivatives, derivatives feed adoption, and the wheel just spins faster and faster.
Just to put some numbers to this, and this data is honestly staggering. Look at the massive shift in just a 14-month window. Alibaba's open weight model family, Qwen, shot up to capture roughly 69% of new fine-tunes. Meanwhile, Meta's Llama dropped down to about 11%. That ecosystem gravity compounds so incredibly fast. It's not just about winning a one-off test on a benchmark anymore. It's about becoming the raw material that the entire world chooses to build with.
But this isn't just a popularity contest about download counts or GitHub stars. It's much deeper than that. Let's move to Section 4, the standards capture phenomenon.
When you choose to build on a specific architecture, you accidentally inherit a whole bunch of baggage. We're talking technical architectures, tooling conventions, behavioral defaults, licensing assumptions, and even governance references baked right into those base weights. We call this standards capture. It is exactly like using someone else's concrete to build your skyscraper. You might not see the concrete once the building is painted and finished, but your entire structure has permanently inherited its shape, its limits, and its foundational rules. That is what winning the stack actually looks like.
Now, we really need to take a quick pause here because there's a massive misconception floating around about data risk. To be perfectly clear, your data risk is determined entirely by your deployment mode, not necessarily who trained the weights. If you are self-hosting open weights completely inside your own internal cloud, your data stays 100% private. The model's intellectual property might be foreign, but your data literally never leaves the building. On the flip side, using hosted APIs from overseas exposes your data externally to foreign legal jurisdictions, like China's national intelligence law, so getting your deployment mode right is absolutely crucial for enterprise security.
So taking all this in, how do enterprise readers actually protect themselves in a world that's splitting apart technologically? That brings us to Section 5, Achieving Architectural Substitutability.
You really need to go to your engineering team and ask them this exact question. If a single government changed its mind tomorrow, would our product go offline? Because if Washington or Beijing suddenly change the rules and your system crashes, your model provenance has officially become a dangerous load-bearing dependency. You've basically built that skyscraper on concrete that can be yanked away at any second. No way you want to be in that position.
The ultimate operator doctrine for surviving this, it's achieving architectural substitutability. You have to keep model provenance as a reversible variable, never a load-bearing dependency. AI procurement is fundamentally a routing problem now, not a loyalty program. Enterprises need to use multi-vendor routing, evaluate on a per-task basis, and always keep self-hosted open-weight fallbacks ready to go. Pulling one model out should never bring down your whole product.
I want to leave you with this final, somewhat provocative thought that really hits the nail on the head for the whole AI stack paradigm. Winning the frontier is winning the race. Winning the stack is owning the road. So you have to ask yourself, are you just trying to win a temporary sprint on a leaderboard with the most expensive model? Or are you paying attention to the foundation, the standards capture and open-weight infrastructure that is quietly paving the road the rest of the world is going to have to drive on? Thanks for joining me for this explainer. Definitely take a hard look at your own architectural substitutability before that road shifts right underneath you.